David talked to us about the hardware and the architecture. What I want to do is give you a quick overview of our dashboard and then jump directly into the new features that we have and tell you about those and answer your questions. So for those who haven't seen the dashboard before, as David said, it's a very simple dashboard, and that's one of the cool features that our customers like a lot. It basically bubbles up into one single thing. If it's a green smiley face, everything is good. If it's a sad red face, everything is something is wrong. And you can drill down to the lowest level of detail from this by hovering. So this does not sacrifice any detail, just kind of bubbles, and I'll show you how. So on the right-hand side, those 4 traffic lights, they represent the different segments of your network. So the Wi-Fi is the Wi-Fi network. There's the SSIDs are there. The network is where your network services live, the DHCP and DNS. And the internal and external are targets that are fully customizable that you want to test. So for example, here it's a mail server or a local iPerf server on the cloud. It could be a Dropbox, or it could be a YouTube test that you set up. So this is fully customizable. Now, what we allow you to do when you look at this is when you hover over anything, it's going to reveal data to you. It's going to reveal 2 things. It's going to reveal the last 24 hours kind of overview of what happened to that element. In that case, I'm hovering over a physical sensor. And it's going to tell me also the latest values, which are typically within 30 seconds that it pulled back from the sensor. So now it's telling me that the sensor is seeing just move now. Next 61 dBm, 108 megabits per second channel. If I hover over any other element, DNS is going to give me the data. If I hover over Dropbox, for example, say Dropbox didn't experience any issues in the last 24 hours. This is the latest latency, jitter, packet loss, upload speed, and download speed that I'm getting from that. Now, this is I breezed through this very quickly. I wanna jump into and show you one of our new features. I'm gonna click on one of the sites that we've set up, and one of the foundational things that we've added to the sensor now is a rolling packet capture on every sensor. Mm-hmm. So the sensor, the way it works, you distribute those sensors and out there in the field where your users congregate. And what they do, they go and try to mimic the user journey. They associate, they authenticate, and they test different services. And they stream the data in real time here. We support different types of authentication. We just added ePeep and ePTLS. In addition, we do captive portal and we do PSK and open. But in parallel with that, we're running a rolling packet capture. And that rolling packet capture allows us to do a few cool things that we just added, which is going to be the focus of my presentation and demo. Just to point out, this is a real-time demo, so pray for the demo gods that nothing goes wrong. We have three sensors over there, and we have a bunch of sensors in our office. OK, so that rolling packet capture serves three things. So let me tell you how it works first. So we're collecting packet capture in buckets of 1 megabyte. We have 50 buckets. So you have a rolling buffer of 50 megabytes of data on every sensor that is moving with time. And what that allows, so the packet capture itself is, we take the header and a snap length of 512 bytes per packet. So it's not only headers, we have data as well with that. You can do three things. If you want, so this is kept at the sensor. If you want, you can pull this data on demand to this dashboard. All you need to do is go here, and then if you click Request Packet Capture, now the sensor will upload all the 50 megabytes, push it to the cloud. It will be available on your browser for you to download a .pcap file. You can import into your Wireshark, and you can do the analysis. So that's the first thing that we can do with this.
Just back up one question.
Yeah.
What was the trigger that made it save it, or is it always the last 15 in the circular buffer?
So the buffer is moving with 50 megabytes. My click here requested that sensor upload the last moving buffer.
Yes, so it's a circular buffer.
Yeah.
So it's not triggered that we save based on some triggered event. It's just always there.
So that's the second thing I want to talk about. So this.
You're welcome for the second.
Yeah. So this is a pure on-demand. Somebody calls you and you say, last minute something happened. Typically 50 megabytes, it's between 6 and 10 minutes of data. So you can quickly request the PCAP file. The second thing that it allows us to do, and this is to answer some of Brennan's question. So I'm going to go back in time. See here, I had a couple of issues. One of them is an SSL issue. So now this is a new feature. When I click on here, I get an analysis file. So what we typically do when we encounter an issue is to reduce false positives, we go into what we call a triage process. We go and confirm that this error existed. And with the packet capture happening, we go into that packet capture file, and we analyze it, and we strip out the pertinent information for that when that error happened, and we upload that by default. So you get around 100 to 200 kilobytes of packet capture with every error that happened. Plus, you get this analysis. So let me walk you through this. So I just found an SSL error that happened a few hours ago. So this is what the sensor did. It checked first that it associated. It checked that the gateway is reachable. It did a DNS check. If you click on any of those, it shows you actually what the sensor did. So it shows you that Linux machine actually ran this command. It ran a dig on that DNS server, and this is the response that we got. You get this data. You know exactly what are the steps that we went through to get to that issue. So it went checking the DNS. It checked if it could connect to the internet. It pinged the host. Everything was good. So it pinged the host, 0 packet loss. And then it tried to access the site. So it ran a curl. And this is the curl output. Everything was good. Went to the point that we got this message from the site. It says, no alternative certificate, subject name, blah, 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 blah. So this is the trigger that got us to conclude that there is an SSL error on the site. And this is when we trigger this issue, and we send you an email notification. If this we do on the Wi-Fi interface. If you have the Ethernet plugged in, and you don't have to have the Ethernet plugged in, once we encounter an issue, we double check it on the Ethernet. So in this case, that sensor is plugged on the Ethernet. We run the same checks. We check if we're encountering the same issue on the Ethernet as well. In addition to that, we've tagged this issue with a packet capture that is not the full 50 megabyte capture. It is just the pertinent information for this issue. So you can download that and actually look at the messages if you want. So that's the second thing I wanted to show you that is related to packet capture. The third thing that I want to show you with that the packet capture allows us to do, and I know some of you guys have requested some of these features in addition to our customers. Analyzing the packet capture on the fly allows us to go deeper into Wi-Fi metrics. So right now, if you go on the right-hand side, if you're not familiar with our interface, all the traffic lights on the dashboard, they collapse into, they can be expanded here. So the Wi-Fi, internal, external, everything, you can drill into the metrics that constitute that traffic light. So on Wi-Fi, for example, I'm looking at bitrate right now, and you'll notice a new feature. Now I can expand that bitrate. And because I'm looking at packet capture, now I can look at EX bitrate, RX bitrate, and also the most frequent MCS code that was encountered during that time frame. So I can give that data. I know Keith is happy to hear that.
Yeah. Yes, that was directed directly at Keith.
Okay. So the other cool things that we've added is packet retry rate. That's also, we get that out of packet capture. Utilization, we get that from the driver, and a bunch of other things, including AP association time, BSID channel, and so on. The rest, I'm going to go through quickly. You can hover on any of those metrics, and you can correlate that in time with other metrics. So I can look at latency, for example, and I can see the components of latency. I can expand here, and I say, OK, so this is the latency to my mail server, my SMTP, and my. So I know if something spikes, is it coming from just one destination or several destinations? The final feature that I want to show you, also some of you guys have asked us about this. The dashboard has 24 hours of live data, used to have 24 hours of live data. What we've added now is the ability to see up to 30 days of live data right there on the dashboard. So you can switch your view from 30 days up to the last hour. So I can zoom in. If you're running, for example, a stadium, that would be an interesting view for you. You can zoom down to the hour. You can go on 24 hours, or you can go on 3 days. That allows you, that takes down the aggregation up to 1 minute buckets. So you can take a look at that data. Finally, on the left here, I want to show you the Wi-Fi environment. We keep on scanning the environment all the time. You can take a look. You can filter your networks, other people's networks. And we have a smart hover feature that allows you to hover over any of the SSIDs and reveal additional information. If you have QBSS enabled on the AP, it will pull up stations utilization from the AP perspective and display it here. So this is kind of just a quick tour. I want to give you an example, another example here of an issue that kind of happens often. Let me see, San Jose. So, see, OK, so you get a call quickly from the site, and the Wi-Fi is not working. It's intermittent. Some clients have access, some clients you don't have access. All you need to do is go back in time to the time that problem was reported. And for example, you can go here and see that DHCP did not return an IP. You can click through, see the triage process. For the triage process for this one is pretty simple. You can click on DHCP, and you know that the reason for the DHCP not working is no DHCP offers. You can click here, and you can see actually what actually did we do. We ran a DH client. We sent a DHCP discover 4 times. We did not receive an offer, and that's how we concluded that there is the pool. There was no the IPs in the pool, and now you can go and troubleshoot that, knowing for certain that this is what happened.
So is there a way to export this kind of into like a report form?
It's what you're going to get here is the ability to click and copy all this. Okay. We just haven't released it yet. So you're going to be able to, you can copy it not right now like this, but we'll have a button for you that you can copy all this stuff.
Okay. Just a detailed question from Twitter. What format is the packet capture in? PCAP NG or PPI?
It's a PCAP, not PCAP. Yeah.
It's a generic format. Yeah. And it can be directly opened in Wireshark.
Does it have radio tap headers on it?
Not specific radio tap headers. It was a custom capture software that was written by our team. Basically, the long and short of it is that we tried to run we ran Wireshark on the sensor.
Yeah, we tried to run like like Wireshark, and those bring up the CPU utilization very high and affect the performance of the sensor. So we wrote our custom tool in C that limits. So we only take 2% of one of the cores. We have 2 cores. It takes 2% of the capacity of the CPU, and it's a custom tool that we wrote that picks up.
Yeah, and it does output it in a standard generic format. Yeah. So we open it up in Wireshark. If you hit the download packet capture button, you can just pop it right into Wireshark and open it up. And it's not just capturing headers, it's capturing headers and data specifically about the transactions and about the 802.11 stream. So
great.
When you talked about features that are coming or features that are soon to be released, what is your thought on release notes and features as far as like selectively deploying to individual sensors, or everybody gets everything every Wednesday, or how does that happen when you release new updates?
Yeah, good question. It depends on the nature of the update. So some updates are fairly minor, and we basically release them as soon as we have them available.
Everybody gets them all at once.
And we usually don't update everyone at once. It's usually a bit like staggered. We have a smaller pool of customers that we work with very closely to as a first release, and then we extend it to everyone. But that window is very short. So, I mean, usually a matter of either hours or just a couple days. In the example of some of this packet capture feature, this is like a really core update. This is a far-reaching update because, as Fouad was saying, it's rolling all the time, and we're doing a lot of stuff with it. And it's new kind of low-level code that we're pushing out to the sensors. So that actually is being released to the first batch of customer devices today, and it will be released to everyone by, I think, the end of next week or middle of next week.
One other quick question on from Twitter. Can your device get past a captive portal's login?
Great question.
Yes. So it doesn't do that out of the box just because captive portals are different and they're designed differently. So, but we're working on kind of adapting to the major captive portals. So if you have a captive portal, we just take a snapshot of the captive portal, and the device has a headless browser in it. So it actually loads up a browser, clicks on accept terms and conditions. If you're in a hotel, puts in the room number, last name, measures that process, measures the redirect time, authentication time, and then the other redirect, and reports it. I can show you. I have a simple captive portal running here. This is how this is not broken down, but this is the data. So this is the onboarding process on a captive portal, and this is how it's going to look like. And if you encounter an issue, also it's going to alert you that this is a specific error that we got from that.
How does it, if I put one in a location and there is a captive portal that requires that, how does it learn how to answer it?
It's a manual process right now. We're going to ask you to send us the HTML code, and then we push it to it, automatically. We test it, we push it to it. If we've done it before, you just tell us we're using Nomadics, for example, and then we'll just push the update to you, and then it starts testing it.
But that also brings up an interesting point, and I think you guys kind of mentioned this, but I think it maybe deserves a bit of a moment here, is that like the sensor can work without an Ethernet connection, right?
Yes.
So what happens if you power the device up with an AC and you need to program it to pass the captive portal?
Well, that's why we have a cellular connection in there. So we never lose sight of that sensor, even if on the Wi-Fi network it's blocked by a captive portal. We can still reach it by a cellular network. And in fact, we've done that a lot of times. And in one instance, I mean, I think that this captive portal discussion is really a good one, where it's a classic thing that anyone who's managing the Wi-Fi network gets blamed for if there's a captive portal issue of some kind, and it's really hard to test if you're not testing it from the user's experience like this. And in one instance, we had a customer with a 90% authentication failure rate during midday. And when they tested in the evening, it was totally fine. It was just a resources issue on the captive portal, but it was undetectable any other way because people already authenticated, so they still had traffic. It was really a thorny issue to try and diagnose and detect without a end user device.
Does each sensor come with the 3G card, and is it enabled by default?
Yes, yes and yes, but we limit the amount of data to 20 megabytes. It's enough to get the sensor set up and to do a little bit of out-of-band connectivity. And then, because if you're connecting it to Ethernet, maybe you don't want that cellular functionality enabled all the time. But if you do, then there's a cellular plan that's optional to pay, monthly.
By the way, the team in South Africa is watching, so hey guys, I don't know what time it is over there, 1 o'clock in the morning or something. We do have radio tap headers. The PCAP file does contain radio tap headers, FYI. Yeah, so they sent me that on Slack. Go for it.
Just a question on that 3G thing. Then you guys had different SKUs, like if I wanted an AT&T versus a Verizon, or are you standardized on one, or what's the?
Yeah, that's a great question.
Yeah, we standardized on one. We use Twilio's MVNO platform, and in the US, that's T-Mobile.
For now.
At the moment, but it roams internationally, and T-Mobile has great roaming partner plans, which Twilio kind of inherits. So it actually has really good international coverage. We've sent this sensor to all kinds of countries where we were kind of hoping for the best that it would come on, and we've never had a problem.
Like Canada.
Like even Canada.
Oh wow, it works there.
Yeah, I mean, and for reference, guys, you weren't entirely sure when we first got our sensor exactly how it was going to work, and it just worked. So that was kind of impressive.
Yeah, I think it was that was about the first outside of the US and South Africa that we tried. So
cool.
Look at that.
Keep the questions coming. So I'm not going to be able to respond on Twitter. So David's going to take over the tweets from now. But you guys are sending out some great messages. We're absolutely appreciative. And the questions, please keep them coming. We're trying to answer them as quickly as possible.
So there's a few more questions about the captive portal authentication. So is that something that we can access now, or we'll be able to do soon?
Yeah. So the captive portal is actually really cool, and we've gone back and forth with it. And I'm sorry I was nose down on the phone, but it does support some of the major vendors out there. So Ruckus, Arrowhive, natively, a lot of the stuff is already products that we've already worked with. So we've already gone through their captive portal. So we have the scripting down. What's funny about it, and it is available right now. It's available right now on the boxes. And what's really cool is if you have your own special captive portal, I was kind of curious as to what the process was for us to do the onboarding of something different. And our development team has this process that takes 16 seconds to capture the data and then a couple of days to put in. So
the sensor doesn't by itself decide to test the captive portal. It will detect it. It will say there's a captive portal. You'll tell us I want to test it. We'll push that update to it.
It will notify you. It'll show up right there red, and it'll light the rest of this up red if your captive portal hits though, because it'll say undetected or unannounced captive portal or something like that. So if you're behind a captive portal, it will tell you.
There was another Twitter question specific on captive portal about can it act like an iPhone or an Android phone, because they have different processes when they hit a captive portal than your Linux box does.
Yeah, so I'll let David answer.
Yeah, to a certain extent, in that we basically tell the portal what the user agent is, but we can't emulate like Mac OS or iOS on the sensor, for example.
We can push through the headers though, right? I mean, you can say, hey, we're pretending to be an iPhone.
And we can basically say, oh, it's a mobile device or it's a desktop device by telling it what sort of screen size it is. So if you've got different captive portals serving different types of devices, we could you can specify which one you'd like to test.
Go for it.
Could you go just in a little bit more depth for those that aren't aware of the cellular portion of the sensor? Just, I know we talked about it a little bit last night, but just for those who aren't necessarily aware of that feature, because I think that's really cool and that super sets you all apart from other.
Well, there's two actually. There's the cellular side, and I'll let David approach that one if you want to talk about that. And then there's the super capacitor side, which is pretty awesome in and of itself.
Yeah, so I mean the cellular connectivity helps in two ways. One is for setup, where you don't need to establish any kind of connectivity to the device. You don't need to set it up with the Wi-Fi credentials beforehand. You don't need to plug it into Ethernet. You just can plug it into power, and it uses its cellular connection to download all of the settings that it needs, from the cloud directly. So you can get that device up online in 2 minutes from plugging it in. Now, when you guys plug it in, because we've got software updates coming in, it might be like 5 or 6 minutes, but it's really quick. And then when the sensor loses connectivity over Wi-Fi, if it encounters a problem, whether it's an authentication problem or whether it just can't connect to the SSID. I mean, I think this is one of the advantages of having a dedicated device, a sensor there that can tell you, hey, I'm not seeing your SSID anywhere, and using the cellular backhaul to get that message to you, so you know that it's not a case of the device just can't connect or people can't connect. This the SSID is totally gone.
Opinion. I mean, if you had a problem with your Wi-Fi and you can't reach the sensor because the Wi-Fi is jacked up.
That's right. And having a sensor.
That's all.
Yeah.
That's all.
So the other one is the super caps on there. I'm going to try and push it a little bit. We're running. I want to make sure that for time we get everything in there. But on the super cap side, so the super capacitors allow you to. They basically, it's a set of batteries on there instead of 1 or 2. I think is there 4 on there?
There's 4 super caps.
There's these big blue capacitors. And what happens is as soon as your device loses power, or if you unplug it, it will maintain power for about 30 to 45 seconds. And in that time, what it does is it runs a quick check and it says, okay, I lost power. Can I still see beacons from wireless LANs? Can I still see what's going on? And it gives you a last gasp of information. So it sends that up to the cloud and says, power outage detected. And it lets you know that, hey, something specific like a power outage happened. In one of the cases of our customers, they had something pretty tragic happen in one of their data centers, one of their data closets, and they wouldn't have known unless we alerted that power outage went down. Ends up they lost some equipment, but they were able to save a lot of it because they were notified that there were a power outage and they were able to get over there. So it's kind of a neat way to add on to that.